3 minus 7 is equal to negative 4. 2 minus 5 is equal to negative 3. 4 minus 6 is equal to negative 2. 1 minus 1 is equal to 0. 5 minus 8 is equal to negative 3. 3 minus 4 is equal to negative 1. 2 minus 3, negative 1. 5 minus 10, negative 5. 4 minus 9, negative 5. And 1 minus 2, negative 1. Now, after this step, we go on to the third step, which is squaring the differences. We raise it by 2. We can see over here, negative 4. Negative 4 squared, 16. Negative 3 squared, 9. Negative 2 squared, 4. 0 squared, 0. Negative 3 squared is 9. Negative 1 squared is 1. Negative 1 squared is also 1. Negative 5 is 25. And the same is here. And also negative 1 is equal to 1 when squared. Moving on to the fourth step, we use the Spearman-rho formula. Here again, we see P is equal to 1 minus 6 multiplied by the summation of D squared over N multiplied by N squared minus 1, where N is the number of paired observations, or in this case, the 10 students. Summation of D squared is the sum of the squared differences in score. So, we just need to add all of this here to get the summation, which is 91. So, when we input the values, it goes to P is equal to 1 minus 6 multiplied by 91 over 10 multiplied by 10 squared minus 1, which then turns into 1 minus 6 multiplied by 91, 546, over 10 raised to 2 or 10 squared is equal to 100 minus 1, 99, which will be multiplied to 10, which we can see here. 1 minus 546 over 10 multiplied by 99, 990. Now, if we divide that, we get 0.5515, 5,515. Now, we subtract 1 with 0.5515, we'll get P is equal to 0.4485, which when rounded up goes to 0.45. So in conclusion, P is equal to 0.45 in this sample problem. And that's all you need to know about Spearman-rho and how to manually calculate it.
So, good afternoon, Sir Louis, or to anyone else who is listening to this. And tonight I will discuss the Spearman-rho, or specifically the Spearman-rho for SPSS, and what exactly is it used for. So first, let's discuss what is the Spearman-rho. Spearman-rho is a type of correlation. It is used in order to find and measure the strength of association of the relationship between two variables in a data set. And this is where we determine if there is a significant correlation between one variable and the other. If they are connected, if they have a strong relationship, or if they do not. And variables could be continuous or ordinal as long as they can form a relationship. Now, the Spearman-rho in SPSS is also used for the same thing, to find and determine the relationship between two variables. But the programming of the SPSS allows the user to easily calculate the hypothesis and acquire the data. So SPSS is obviously a statistics site or app for processing and acquiring the data easily. No need to computate it manually, and as long as we know how to operate the SPSS, acquiring the data that we need is very simple and easy, and that's what we shall be doing today, or tonight rather. Now, Spearman-rho in SPSS, what do you use it for? What do we use it for? What are its possible uses? So, First and foremost, obviously, research, determining data, like I said, determining data or the relationship between two variables in a data set. And as you can see here, you could also use it to look for nonlinear relationships, ordinal data, or data sets with outliers. As I said, as long as we know how to operate the SPSS, we could easily look for the data that we need, including these three. Next is corporate use. Corporate use, we could use it in corporate settings and other such things like comparing company data, what determines what, company stocks or inventory, or even company performance of employees, or if there's a strong relationship between what pay and motivation to to work. Yes, that also counts. That is a very acceptable way of using the Spearman-rho for SPSS, or just a Spearman-rho in general, rather. And of course, for commercial use, or we could put it in personal use as well. So anything personal that we might need to use the Spearman-rho in SPSS for, anything goes really, as long as there are two variables that we could compare, and as long as a significant relationship could be formed between them, this SPSS is applicable. Now, I shall present a statement problem or example to show you how the SPSS um, performs its calculation for the Spearman-rho. So let us read the statement problem first. A researcher wants to examine the relationship between students' time spent on independent study and their academic performance in a specific course. The study categorizes study time into ordinal groups, e.g. 1 equals less than 1 hour, 2 equals 1 minus 2 hours, 1 to 2 hours, rather, 3 equals 2 to 3 hours, and etc. And rank students' academic performances equals 1 for lowest, 2 for the second lowest, and so on and so forth. The researcher has then collected data from 10 students, and this will be the data set we would be using. Very small, but it's enough for what we're about to do today. After all, it's only an example to show the capabilities of SPSS in calculating the Spearman-rho. So we shall move on to the SPSS to show you how to perform this